Hello, everyone, and welcome to our next ADW session, Data-Centric Transformation, Why Now?, which will be presented by Dave McComb, President of Semantic Arts, and Brian Platz, Founder and CEO of Fluree. All audience members are muted during these sessions, so please submit your questions in the Q&A window on the right side of the screen. And Dave and Brian will respond to as many questions as possible at the end of this talk. So let's begin our presentation. Thank you and welcome, Dave and Brian. Take it away.
Thanks, Laura. Well, we've got a lot of material, so we're going to move pretty rapidly. But I wanted to start with something. We get involved with a lot of large enterprises, and we go from place to place and see everybody's got these gigantic, complicated enterprise architectures with lots of boxes and all this kind of stuff. And rather than recreate one of our client ones, I thought I'd have a graphic artist take kind of the average of everything he'd seen in all these enterprise architectures that we've wandered into and represent that. We're going to use that kind of as the base case here. And I think this will be familiar to a lot of people who've actually worked in enterprise architecture. I think you'll recognize that little hairball in the middle there is SAP, or it's really the 6 instances of SAP you have that are probably not very well integrated right now. And along the bottom there, you've got your Informatica and your ETL, and over there at the right, you've got your warehouse and now you've got Snowflake, and so that's good, and Hadoop and Mongo and big data and all that kind of stuff. But that's kind of the state of the art of enterprise architecture as we've witnessed it recently. If I were to just characterize that, I would just say it's a mess. Every place we go, it's a mess, and it's getting worse. Every one of those lines is someone's attempt to reconnect something that shouldn't have been disconnected in the first place. What is weird is that everyone accepts not only that diagram as if it's business as usual, but the fact that let's spend $100 million on adding a few extra features to a system we already have, but which requires us to re-implement it. It's so strange. There's this story of the boiled frog, and it may or may not be true. I didn't go boil any frogs for this presentation, so no frogs were harmed in the making of this presentation. But we've been sitting in this for so long, and everybody comes to work every day and learns what they're doing, that somehow it seems like it's okay. Just to give a slight idea of how not okay, and everyone just accepts it as okay, things are. When the ACA healthcare.gov first rolled out, literally the very first week, one of my developers came in and said, gee, I have heard of this system, and I hadn't heard of it at the time. I've heard of this because we weren't in healthcare. I've heard of this system that has 500 million lines of code. What could you possibly need 500 million lines of code to do? And I said, I don't know, get out a pad of paper, let's go through and see what they've done. And we just went screen by screen, page by page, writing down how much code do you think that would be? How much, we got maybe up to a few thousand. And we said, yeah, what is the other 500 million lines of code in this thing? And by the way, it was a terrible system. Right after that, I ran into the guy who's CEO of Top Coder, which is this company that puts together challenges, and they get a team of programmers to build something. And by the way, by the time it rolled out, I later found out that they'd already spent $500 million on this thing. And I told this CEO from Top Coder, I said, this is probably the size of scope of one of your Top Coder challenges. For $50,000, if we can find a sponsor to put forward $50,000, we could probably recreate this thing. And just as we were out starting to look for it, life imitates art, we came across this site called healthsherpa.com, who built the equivalent of healthcare.gov in about 6 weeks. I've had several interviews with the CEO and with a team that was about half the size when they started. This is what the team is now. There is no way in the world those 12 people could have spent $500 million in 6 weeks. I mean, it's ridiculous. And the system they built was and is far better than healthcare.gov. Healthcare.gov ended up stealing a lot of their ideas. They called it healthcare .gov Lite. That's so patronizing, but anyhow, these guys proved that some of these systems we take for granted to be gigantic and expensive, et cetera, really are just small projects. Another one of my favorites was the Victoria Sheriff's Department put out a project they have cameras on the front of their cars. They wanted to use that camera to take pictures of license plates and check whether the car was stolen, plates expired, things like that. Well, it turns out a programmer in Australia named Tate Brown found out that project had been launched and it was awarded for $86 million. And he wondered how much of that could you have done with open source? And he discovered that most of it, in fact, this code on the right is about half of the solution. The whole thing is about 100 lines of code. And he put it to his camera, would drive around Melbourne and find stolen vehicles. I mean, at some level, you say, what is going on that somebody thinks 100 lines of code should and did cost $86 million? I mean, some really crazy stuff going on. My final one, Canadian Firearms, was a project, was originally supposed to be $2 million. By the time it was canceled, it was $2 billion. And they had registered something like 2 million of the 8 million guns that exist in Canada. And when you think about it, and there's only a few dozen attributes per gun. And when you think about that, you think, well, I could get about 1 million rows in an Excel spreadsheet. It would take me 2 or 3 Excel spreadsheets to do that, but certainly not $2 billion. I mean, there's something quite rotten in the state of Denmark here. And these things aren't isolated. These are public. It's easy to get data on them, but we work with a lot of large enterprises. We've seen billion-dollar systems flushed. We routinely see $50 million projects that could have been done for far, far less than that. So we did some root cause analysis, and we said, what is it that is running the price up? And there's 2 things here. One is we've allowed things to become unnecessarily complex. And when we're talking about unnecessary complex, we're not talking about 10% more complex or 50% or even 100%. We're not even talking about 10 times. Most of the things we look at are at least 100 times more complex than they need to be to solve the problem at hand. And there's this discipline we call application centricity, which says it's a mindset that says I have a problem to solve. I'm going to go build, buy, or rent an application to solve it. And before you know it, you have a lot of systems, and that's the problem. So we're going to just take a real quick look at application centricity. Most executives, other than farmers, lament the fact that they have silos. They say, oh my God, we have all these silos, and that's the problem. And then every time they launch a new initiative, they create a new silo. And they haven't made that connection between the fact that it's what they're doing is creating the silos. And most large enterprises have thousands to tens of thousands of independent databases with their own data model, data schema, all that kind of stuff, completely different. So we wanted to find out where silos really come from. And we planted some hidden microphones in boardrooms and did some sleuth work and discovered here's where they come from. First thing that happens is there is a business problem. Something has gone wrong, and some executive says, uh-oh, what should we do? We gather a team of pretty smart people, and they try and figure out, well, we need to reorg, or let's call him McKinsey, but half the time it's, oh, that's an information systems problem. So they turf it over to a different group of people. Okay, we're going to go figure this one out. And sometime after about the 4th or 5th meeting, they come to a point where they're going to make a decision. And they think that it's an important decision. And they think they're going to just, it used to be they decide between build or buy. Are we going to go build a solution to this, get our own programmers and custom build it? Or should we go out and buy a package that solves this problem? Nowadays, there's a third choice. You can rent a solution. You know, that's what software as a service actually is. But while this feels like a choice, actually, it's a non-choice, because every one of those, build, buy, or rent, brings with it its own completely unique and completely arbitrary data model. And if you repeat this process thousands of times, which most large enterprises do, you will end up with thousands of silos. Every one of these snowflakes is a new and interesting and unique way of describing the exact same thing we've got in hundreds of other systems, whether that's inventory or people or employees or workers or claims or whatever it is. It's in there. We just did some work. We're doing some work right now with an insurance company, and they're studying their silos, they're profiling, which is a good thing to do. And they discovered that they had 8,300 instances of Social Security number in their many various systems. And they weren't all called Social Security number. Obviously, some of them are tax ID and user one and SSN and whatever else it is. But the fact that you got that in 8,300 places is indicative of the problem. In a properly designed system, as we're designing for them, as we're going to talk about here, and as Brian's going to share with you, you would have that in exactly one place. And I know it sounds kind of crazy, but that's where we're going. So here's what's in enterprise applications. There is code. Like I said earlier with the healthcare.gov, there is 500 million lines of code that access a database, which is theoretically shared, although not shared very much, only shared within the application. So shared amongst the use cases, but not shared with anyone else, frankly. And that code's job, one of its jobs, is to present a user interface. And there's this beautiful little picture that everyone buys into that says, that looks sensible. 3 levels, 3 tiers, separation concerns, but there's all kinds of things wrong with this. There's no layering here at all. If you go read this code, what you'll find is nearly half, or somewhere around a third of all the lines of code in this middle layer make some reference to the schema or the API that attaches to the schema or the names of fields on the forms, or somehow they're talking about the data domain, but they're doing it in code. And so because there's so much code and so many references to such complex data, that just multiplies on itself. The database in turn is dependent on the code, because every access to that has to come through this code, because if you didn't, you wouldn't get authorization and validation and constraint management. All that good stuff is there in the code. And the user interface is dependent on the code, because all that code has to move stuff from the database to field 2 and form 3 and all that stuff. So anything you change ripples all the way up and down. There's no separation concern here. And this isn't inherent in this approach. It's just what happens, because, agile programmers are heads down, doing as much as they can, as fast as they can. And when they need another data item, they just add it, and you watch what happens. And there's 10 to 100 times more schema complexity, and therefore 10 to 100 times more code complexity, and therefore 10 to 100 times more UI complexity than necessary. So what's the alternative? We call it the data-centric approach. It's, you don't just flip a switch, you don't just buy a product. That's probably the main reason this is so slow to take off. It's a discipline, and a firm is data-centric to the extent that the application code is very loosely bound to, and I've got my 5 adjectives here, but it's a single, simple, extensible, federatable, shared model. And I think I've got some slides to say what that means. If I don't, I'll just extemporaneous it. Oh yeah, I guess I don't. So single is, there is at the center of even a complex enterprise, a very simple, shareable domain model that has fewer than 1,000 concepts total, whereas most of the individual applications have far more than that per application, and there are thousands of applications. So it's a little interesting that it could be that simple, but it is. Simple is just that. Extensible means we want one model that covers how all the key concepts of an enterprise fit together, but you can specialize that in a given application, add a little bit as long as you're conforming to the core. Federatable means you don't have to put all the data in one place. In fact, it's probably a pretty good idea not to, not only for performance and signal to noise, but security, all kinds of reasons, and even potentially leaving data where it is in its relational database homes, and that you want to be focused on sharing this model. building a consortium, doing something like that. So we find it's possible to become data-centric with traditional technology, but man, that is the hard route. I've talked to some people who've done it. It's a lot of work. Even doing it the easy way is a lot of work, but let's take some work off the table here. We think there's three kind of key pillars or legs to a three-legged stool, or whatever analogy here. First one is using a graph database. This helps a lot. It buys you flexibility. It buys what we call integration almost for free. This is where you get rid of your data silos. I'm going to very briefly go through over there. On the right is the traditional relational representation of some information about James Bond in this case. Every piece of data in a relational database, and by the way, most data in semi-structured and even a lot of data in natural language can be expressed in this digraph, this directed graph, which is just a node, an edge, and a node. And in this case, we're representing that one cell down there in the middle at the bottom that says 007's last name is Bond. That is they call it a triple, but turns out just going from tables to triples gives you some incredible flexibility. First thing is you don't have to have already had columns and schema and everything predefined. Once we discover, wherever we discover it, that 007 was assigned the Rolex number 23, which is a very special one. We don't have to have done a lot of pre-existing metadata work. We just have to have discovered this fact, aligned it, and connected it. By the way, this is kind of PowerPoint shorthand, but where you see that colon in front of 007, that's really shorthand. There's a much longer prefix there called a namespace, but the namespace plus this fragment here gives you an identifier that is globally unique. In this case, it's probably Her Majesty's Secret Service, UK.co or whatever it is, underscore 007 or something like that. What that one thing does for you is suddenly says, if it's a globally unique identifier, you now no longer need metadata in order to snap a graph together. So in the old days, to put two tables together, you have to have pre-existing knowledge of the names of the tables and then you have to write a query to do that. When we say integration almost for free, this is what it is. And this graph can just keep getting extended. When you find out that Rolex watch contains the Garrett, you just add that in. This is why most of these pictures, these graphs, get big and complex, but that's both the power and you have to figure out how to traverse that. Second leg is semantics. It's the study of meaning. There's a W3C standard for this. When you build a model around this, that's an ontology. And our contention is that leaning into this style of modeling what something means, not how you want to structure it, is what makes the resulting model so simple. If you use a well-vetted upper ontology, we have one that's for free on our website called GIST. Use that as the basis. It kind of helps with the rationalization, reduces the complexity of the result. It's easier to integrate. And also this standard allows you to run inference, allows you to do reasoning over the data you have. And I'm not going to, in the interest of time, I'm not going to read through that example, but just suffice it to say, reasoning is a pretty interesting and powerful thing. And then the third leg to this we call model-driven everything. It's based on the observation that a lot of enterprise applications are very repetitive. Their forms and their tables and their charts and their, drop-down lists, a few things like that. And once you realize the repetitive nature, then you can write essentially one piece of code. It's really a piece of the architecture, and build a model of the user interface, or build a model of the constraints, or build a model of security, or you're building a model of each of those things that we used to write code for. And the advantage is the amount of code drops drastically. The time frame comes down, because as soon as you're done with the design, essentially you're ready to go live. It's a pretty fantastic benefit. It's been proven out in a number of industries and products. So that's a key part of this. Now, what people are discovering is if you want to go this route, you do need an architecture. The existing architectures, that scribble picture I showed you, is not actually a great place to start. If you bring all the data together and put it in a graph, it still needs a few other things. We've been holding a conference for the last 3 years where people come together and think about what needs to be in this architecture. And we've been drawing this data-centric picture where obviously if it's data-centric, data better be in the center. Those little grapefruit things are different repositories of data, and the various layers around it are meaning and authorization and validation and constraint management, behavior, things like that. I don't want to go into a lot of detail on this other than it's both necessary and possible. There's nothing magic here, and it's a great segue to Brian, because Brian's company Fluree have implemented a data-centric architecture, and in fact they even use concentric circles, so therefore it must be compatible. So with that, let me hand the mic over.
Thanks, Dave. Great. So the screen is shared. I just want to remind everybody that we do have questions open. There's a little bit of delay from what you're hearing and when we're speaking. So if you do have questions, putting them in the Q&A will allow us to get to them as soon as we're finished here. And I appreciate the comment, Dave, about the two circles. So if they're both circles, they must be compatible. So I like to think of a lot of change and evolution that we do in IT is kind of the crawl, walk, run. And so I'm going to talk a little bit more about what I would say the run stuff is. What's the crawl? The crawl is oftentimes I use the term or phrase that if you want to get yourself out of a hole, the first thing to do is set down the shovel. Just don't keep digging it deeper. And so I always think that's an opportunity when you're looking at a new app. Are there things with these concepts here that could be pulled in that allow you to not make the hole any deeper, at least leave it where it is, and maybe even add a little dirt back into the hole? The walk, I think, is what a lot of what Dave covered, and some of these key advantages that moving more and more systems to this approach, some of the benefits that can happen there. And then I think what we're walking into is this idea of data ecosystems. And data ecosystems, I think, need to sit on this type of architecture to be successful. Data ecosystems, I think, are going to be critical for most organizations to participate in some way or another. We already hear a lot about digital supply chains or digital twins. Digital twins is more tracking physical goods in a digital sense, but there's a lot of digital only goods now that need to be tracked and proven through organizations. We have some issues going on right now in the advertising space. Google and Apple are about to shut off the ability for people to track you across websites or across applications. And while that's great for the consumer, it's really detrimental for advertisers. So how do the advertisers still discover information about consumers without these sort of third-party ways of connecting them together? And today that has to be done through primarily third-party data brokers. But there's ways through, types of cryptography like multi-party computation where you can actually combine your data insights with even your competitors' data insights without ever having the data leave your application. But what does that require? It requires what we talked about. It requires a layer of semantics, a global schema that information can be compared across. And in that, you can actually, get insights from each other without ever disclosing your data. You end up disclosing mathematical formulas that end up allowing you to get demographic information across different data sets. We're doing some work right now with Department of Education around verifiable credentials. I call this data containers. To me, it's the ultimate data ecosystem where consumers, perhaps in a digital wallet on their phone or some other ways, are actually holding data that has personal information in it. Could be a health record, could be your driver's license, could be a passport. In the case of Department of Education, these are your transcripts, these are your university degrees that you're holding. But because of these concepts that Dave talked about, we're able to actually bring them together into effectively a decentralized global database. I just had a conversation yesterday, in fact, with one of the top AI data scientists people who came out of the financial services industry. And they're already starting to say, he's at least already starting to say, that the opportunities to get insights out of your data is already getting exploited very well in financial services companies. And the next frontier for them to be able to gain advantage against each other is to start combining data, not just inside their four walls, but start combining it with additional domains of data, combine it with weather data or consumer data that's in other locations. And again, what do you need to make this possible? I mean, you really need all of these things that Dave talked about. So this is definitely where we're going, these sort of concepts. I think as Dave articulated very well, is a move from an application-centric approach to a data-centric approach. One of the things that I wanted to highlight is these two different approaches really require two different sets of problems that we're solving. So when we think about something like a database, the databases that we have today are designed for an application-centric model, not really a data-centric model. They're designed for an interaction model that is one-to-one. This is the only thing writing and reading the data is the app server. It's the only thing that has access to it. Maybe you have a data lake and some ETL process out the back end, but it was designed to only ever talk to one thing. One thing's going to do all writes, one thing's going to do all reads. This data-centric world enables a potentially many-to-many world. There may be many writers of data. You imagine that, many organizations writing to common databases, and certainly many readers of data. So we need to rethink concepts and how they are in the architecture today. Things like security. Well, in an application-centric world, we encode our data security into the app server. And again, it's a one-to-one model, so who cares where it sits? The only thing talking to it, writing to it, is the app server. So if we want to write it in custom code in the app server, that's fine. But in a many-to-many world, we can't do that because we no longer have a single path directly to the data. There can be multiple paths. So we need to think about things like data-driven security that's co-resident with the data, the idea that data should be able to defend itself. Things like capacity. In an app-centric world, it's centralized, relatively fixed, right? There's a lot of control over the application, the usage, so your need to scale the infrastructure to support your app goes up and down. But in a many-to-many world, you don't have direct control over the consumption. So we need architectures that are very dynamic, that can scale up and down, that are very cloud native, so that when a lot of users are accessing information, that we have the ability to scale up very dynamically, but in a global way, not even just an isolated way. Things like cross-data analytics, Dave covered this well. We normally turn to ETL processes to try and combine data sets. There was a recent stat that came out, and I apologize, I don't recall the source off the top of my hand, but that about 30% of IT budgets are spent in data integration. Where in this data-centric world, I like what Dave termed it as integration almost for free. And of course, external consumption of data in our application-centric world, we're building custom APIs. I think the travesty of custom APIs is that not only does it cost you a lot to build, but you impose that cost now on every consumer of your data, because now they have to write custom code to integrate to your custom API, and they have to commit to maintaining that over time, just like you do. And I think it's no surprise that a lot of our security breaches end up coming in this particular category, and it's because it's a lot there, it's a lot to maintain, and there's a lot of parties involved. But data-centric, it's a little bit more native. So what are some of the pieces that we need in place to do this? So this is our circle. At the foundation to create a data ecosystem, you need trust. If data is coming from different sources, and this might be useful internally as well as externally, but you need to know where the provenance of that information resides, how it got into the system that you're looking to, and that it hasn't been tampered in transit or anything like that. We have great cryptography now. This is pretty easy to do. It just can kind of happen in the background for you. Of course, semantics, we talked about that, a common language. Security, we talk about data-driven security. Being able to enforce rules based on current state of the data is very powerful. It avoids us from having to create, thousands of security roles to do all kinds of these granular things. Instead, you can look at security via data relationships. I can see an employee's salary if I'm somewhere up their management tree. And again, in this graph world, we can support things like recursion quite simply. So expressing that as a rule is actually pretty simple, but trying to build a whole series of roles in a traditional system to enforce even something that simple can be complicated. But of course, these can become even more complicated than that. And this model really solves a lot of that. When we share data, we need to understand time. I'm a big proponent of these ideas that we need to be more collaborative around data for us to be successful. I don't believe we have a model in place to collaborate around data. And traditional databases were actually fundamentally designed to destroy data and change on a millisecond by millisecond basis. So if multiple parties need to collaborate around a piece of information, how can they do that? There's no way for them to have a common view of the world. And this is where things like time travel, I think, become critical, because you can lock in data, version data, if you will, at a different specific moment in time. And now you've introduced the ability for people, two systems, perhaps from two different companies, two different parts of the world, to actually have a guarantee that they're looking at the same things and it's not changing. And with that guarantee, you can make decisions. And then, of course, data sharing becomes critical. So sharing, we're big proponents of obviously semantic graph technology. But one of the beauties of graph is that you can represent a lot of other data types with it, including relational databases. So sharing should be able to sit on top of these, where we don't need to build APIs to share data. We can expose SQL or GraphQL or Sparkle endpoints and allow anyone to just query and describe the data they need, instead of building 100 APIs to get them the data in 100 different ways. And we can do that because with the time, with the security, with the semantics that come before it, effectively every user can have their own custom database that only has the data in it that they can see. And therefore we can open these expressive interfaces to them, and we're basically giving data a chance to get to where it's needed the most. So we try to describe these data ecosystems along this interaction model. Like I mentioned, the typical database is designed around a one-to-one model. There's one writer, there's one reader, and that's the app server in front of it. A data exchange or a data fabric is going to be a more many-to-many model. And again, those writers might not all be within the same organization. They can be in multiple organizations collaborating around common data sets. There's data as a service, which we've heard about quite a bit, which is a one-to-many. So it's one producer of data, but they're exposing it to many, but in an expressive and simple way, not necessarily through hundreds of specific APIs that have to be custom coded to. And of course, data virtualization is more a many writer to one reader. So we're representing multiple data sources. And knowledge graphs, I think, while they're not a one-to-one sort of translation of data virtualization, they're a more abstract model sitting on top of it, but I think it's a good example of this sort of concept. And this one-to-many, many-to-many is the world that I think most organizations need to move towards quickly to take advantage of some of these capabilities. And again, this needs to sit on top of provable identity, cryptography, provenance, semantic interoperability, governance, etc., to be able to leverage it. And what are some of the use cases? So certainly these concepts that we're hearing a lot about right now, which is data fabrics, inside an organization, I think all of these concepts still apply, but they materialize in something like master data management. These technologies and these ideas are, a natural fit for solving those problems, locking in things like time, making sure that multiple systems aren't stomping over each other's data, having the provenance there to be able to understand what's happening, how data changed over time. Verifiable credentials, as I mentioned, I think is one of the most exciting things happening right now in data. It's still very early, this idea that you can create data containers that can live anywhere. They can contain privacy related information, but they allow people or anything to prove things about themselves. They can be chained together. And anyone receiving a credential, which is typically tagged up in JSON LD, so semantics technology using a global schema, anyone receiving those can independently validate that they're authentic, who issued them, and it really puts privacy and data into the consumer's hands, but allows us to create effectively a giant decentralized database. So these are some of the areas I'm really excited about, and yeah, we'd love to open up questions.
Great, and we got one. Let's start with this one. Luis Hernandez says, isn't the source of data most of the time coming from an app-centric approach? And should this way of creating data change for the data-centric approach to be successful? Yeah, it's a great observation. It's dead on. What we're seeing in most of our clients is the initial few projects takes data out of app-centric databases and puts it in a knowledge graph. And at that level, it just sort of looks like another data warehouse. And maybe it's analytics or a little bit more. But then the magic pivot is, unlike a traditional data warehouse. In a traditional data warehouse, you're forever beholden to the upstream systems that are feeding you things, because you cannot write a transaction-based system on top of your warehouse. Whereas in the graph, you can. Once you get comfortable that all of your data is in there and represented at its full fidelity, you begin writing just small independent use cases that are not monolithic apps, but only dependent on the shared data model. And then you start looking upstream and say, well, if I just start taking features away from those feeding systems and do it directly here, I can skip all that stuff and eventually get myself out of this mess. Do you want to add anything to that, Brian?
No, I think that was a really great description, Dave. I'll take the next one if it's okay. It's about verifiable credentials. So that was something I brought up.
Yep.
Proof of COVID vaccine, proof of negative COVID test. Oh, I guess it was less of a question, more of a statement. But yeah, absolutely. Verifiable credentials, the way we're thinking about them now, I think is the right way. There's simple things we want to express. So there are some states, Colorado is, I believe, already starting to issue now a digital driver's license effectively. So when you get your new driver's license, there'll be a digital one. I don't believe they're fully leveraging the VC standard, but kind of an earlier incarnation of it. We know, because we've talked to them, Department of Homeland Security is looking to do this with US passports. And there's another organization, I'll tie it into financial services, which is LEIs, legal entity identifiers. And this became the requirement for financial companies, mostly out of the financial crisis, to be officially registered and prove that they're a financial business. And there's a global organization that manages all of this, and they're looking to leverage verifiable credentials, but in a way that they're chained. So they issue a credential to authorizers, basically people who are able to then authorize companies or organizations that are able to authorize financial services companies as legal entities and issue them identifiers. So they take this global authorization ID, and then they actually issue an ID for a financial services company. And you end up getting these nested credentials that they're kind of like those Russian stacking dolls. It's a credential inside of a credential inside of a credential. And you have this way of representing information all the way back to the source. So not only is that part exciting, but they also offer a path to authenticating users without knowing who the user is ahead of time. So right now, of course, we're used to logging into everything with the username and password. But imagine being able to express that someone can use this service if they're a US citizen, something simple like that. Today, our way of accomplishing that would be we'd have to get all 300 and whatever it is, 30 million people registered as users in our system, and then we'd be able to know that we were authenticating them. But instead, people can present these credentials to authenticate into software. Not only am I a US citizen, I'm currently enrolled in this university, and my GPA is X. And based on that and being able to prove that, that might get me access to certain information or certain resources. So verifiable credentials, I think we're going to see very simple use cases, like you mentioned, COVID vaccines, things like that in the short term. But they're very, very powerful concept that I think are going to change quite a bit about how we think about data.
Excellent, guys. I'm going to just jump up here and join you and wrap things up. But while I'm a few last minute notes for everyone on the line, feel free to add any additional questions. We do still have some time. It looks like we have a question that just came in from Peter. So actually, I will delay my closing and we'll go with Peter's question.
Although I was going to jump the queue and take one of the earlier questions, which was, does everyone hear birds? Turns out I'm in Cabo San Lucas. I forgot that I had committed to this webinar, so I'm down here on vacation, and there's a lot of very noisy birds here. Anyway, Peter's question. Enterprise transformation to application centric to data centric would have to be step by step, but where in the system landscape is the best place to start? Oh, that's a good one. Do you want to start that one, Brian? And I'll follow up.
Yeah, I'm happy to start it. Actually, I'll mostly start it with the question to you, Dave, because you're working with I think a pretty broad set of customers. I mean, what sort of industries do you feel like are adopting data-centric architecture? And what ontologies or how are they getting started? And I think indirectly that'll answer this question at the same time.
Yep. Two things. One, almost all industries, but it's only the early adopters in each one. But financial services is in a big way. Pharma is in a big way. Insurance is just starting to get in. They're typically laggards, but we have some folks in the insurance industry, electronic games, people who sell data for a living, the Standard & Poor's and the Dun & Bradstreets of the world, International Monetary Fund. There's lots and lots of divisions getting into it. How do they go about it? We preach this approach that we call think big, start small, and it's based on the idea that the thinking big part is get your core model, get your enterprise ontology at least partially, approximately correct before you do too much work, because what we don't want to do is go build semantic silos. So that think big part says get most of the connective tissue going, then just grab any subdomain where you can show some value by integrating data that was previously hard to integrate, then just bring data together into the graph. Once people see it, they then understand it just sort of grows out organically.
Yeah.
Brian, you want to add to that?
Yeah, the only thing that I would love to add is that I think a good opportunity for a lot of companies today to dip their toes in this in a non-disruptive way is around the idea of data catalogs. Mm-hmm. It's an opportunity to start organizing the data assets, understanding what they are. It doesn't have to be perfect, but in that effort and by making them effective, you're also aggregating some amount of metadata about these data assets. And whether you're trying to serve them directly through a single portal, or you're really just increasingly reaching companies, just want a place like a Google search engine kind of place where they can go and say, hey, I'm looking for where data assets are about this type of information. And perhaps even, get pretty granular with those requests, especially in organizations that have an immense amount of data assets. That provides a huge amount of value. It provides a central place to start thinking about data assets. And I think it's a good way to start, getting the organization aligned with starting to, take the first steps.
Yeah, you just remind another great place to start, I think, is things like GDPR and CCPA, because like the example I talked about, and then add that to the catalog and the metadata. The example I talked about earlier, once you realize that you have social security numbers in 8,300 places in your various systems, and somebody shows up and says, oh, by the way, I would like to be forgotten, and you have 30 days to go find all 8,300 references. I mean, at some point you said, we're going to need mechanical help to get this done.
Well, great, guys. I don't see any additional questions just yet. You're welcome to hang out for another minute or so, see if anything pops up. But other than that, I definitely want to thank you. This has been a great presentation. Thanks to all our attendees for tuning in. Please, attendees, complete our conference session survey on the bottom of the page for each session that you attend. And the next sessions will start in about 10 minutes. Well,
thanks, everyone.
Great. And thanks, Laura. Take care.
Thank you.